Alright, ladies and gentlemen, I hope you worked well on 8.1. I hope you was able to figure out a little bit about product of a power. Now, in the product of a power, you were dealing with powers being multiplied together. Okay, and we also had some on there that were being powers taken to another power. In both those situations, we found out the shortcut, figured out the rule. Now, in these situations, we're dealing with division. We recall that this line here means dividing. So, when we were multiplying powers together, we added their exponents. So when we're dividing, what we're going to do is the base is going to stay the same, and the exponents will be subtracted. So 14 minus 8 is going to be 6 to the power of 6, and we can write our answer using exponents. Okay? Hopefully in your homework you were showing these steps. I did ask you to try 1 through 10, and hopefully you're on track there. Alright? Same thing on the negatives here, and that is when you have a base that is a negative and has the negative in the parentheses, you must keep that in the parentheses. So we'll have 7 minus 2, and that's going to be negative 5 to the 5th power. And there is your end result. Okay? In this one, notice we have a product of a power up top. In the product of a power, when they multiply, that would be 5 plus 3, which would make 12 to the 8th. And then you still have 12 to the 4th on bottom. Now that we've taken care of the product, you need to take care of the division. And that would mean that you'd have to have 8 minus 4. And that would become 12 to the 4th. Remember to use your answers as exponents. Okay? Now, in number 6, if we were multiplying a fraction, that's actually 3/4 times 3/4 times 3/4 times 3/4 times 3/4. There's 5 of them. How many 5s do I have on top? 3 to the 5th. How many 4s do I have on bottom? 5. So that's 4 times 4 times 4 times 4. And there is your final answer. Just write them using exponents. Okay? Notice this one looks very similar, or a shortcut would be that this has an exponent of 1. There's only one 3. This has an exponent of 4. There's only one 4. So, power of power rule would tell me that 5 times 1 would give me 3 to the 5th. And then 5 times 1 on bottom would give me 4 to the 5th. And that would be the shorter way to find your answer, especially if this exponent was like 20. We wouldn't want to write all those out to see them. Okay, number 8 is a fraction times another fraction. So we have 3 to the 8th power times 1 on top. That just equals 3 to the 8th. And then on the bottom we have 1 times 3 to the 1st, which is 3 to the 1st. And when we subtract these, we'll have 8 minus 1, which should equal 3 to the 7th power. And there's your final answer there. Alright, notice number 8, number 9, and number 10 are all very similar, so you should be able to figure those out. That's all the help you have with what was assigned last time. What's going to be assigned this time is going to be the remaining of the worksheet on the front, 8.1, and on the back here. I'm going to work some of these down here in this open space because these ones take some extra steps. You have an example used for number 10. Number 11 is a tough one. It has a lot of different parts on number 11. Okay, so let's talk about number 11, and we have to first start with a power of a power, meaning that the base of 3 has an exponent of 1 because there's only one of them. The x, there are already 5 of them inside. The 10 also has an exponent of 1. The y has 2 of them on bottom, and all of that is being taken to the exponent of 3. So that means we're going to have to do 3 times 1, 3 times 5, 3 times 1, and 3 times 2 to change all 4 of those exponents with those bases. On top of that, we're going to have a product taking place between 5 and 4 of the x's. So let's go ahead and reduce this. I need to reduce the powers in here. The base of 3 will now have an exponent of 3 when that multiplies in. The base of x will have an exponent of 15 when those multiply in, because that's a power to another power. The bottom of the fraction is going to have 10 now to the power of 3, because 3 must multiply with 1, and there's now going to be 2 times 3 making 6y's on bottom. The top will be multiplied with 5, and the bottom will be multiplied with x to the 4th. Now, if I have 15 x's on top and I have 4 x's on bottom, I can subtract those, and what's actually going to take place is that there's going to be 11 remaining on top. If we can have those x's on top be greater than the amount on bottom, it's going to stay positive, so my answer will stay on top. That's going to leave 3 to the third times, I'll go ahead and write the 5 next, times x, and there will be 11 x's remaining on top. On bottom, we're going to have 10 to the third power, and we're going to have y to the 6th, and that's everything that's on bottom. The y's do not change because there are no y values on top. We could solve this out, and 3 times 3 times 3 is 27. 27 times 5 is actually 270. 10 to the third power is 1,000, and so you could change that number if you want. I'm going to leave my answer like this for now, and we'll talk in more detail about this on Friday whenever I come back. Okay? So you can see number 11 has quite a few parts to it, but we have it conquered, it's done and taken care of. Number 12 is pretty similar to the fractions up top that we've already looked at. I think 6 and 7 were their numbers. Okay? Number 13, make sure you take the outside power and multiply it with all of the bases inside, and you should change those exponents. Number 14 is very similar to 13. Take the power outside, multiply with each exponent inside. Number 15, power outside, multiply with each one inside. So what I'm telling you is that this is very similar on all those. Same thing with 16. And it looks very similar to this step that we took care of on 11. Okay? So on 17, let's take a look at it, since maybe it's a little bit different situation. We have 2x to the 4th, y to the 5th. Then I have 4x squared, y to the 7th. This one takes a little bit of knowledge on fractions, which I know isn't our strongest point, but hopefully this will make sense when I write it out. What actually takes place on our shortcut of subtracting from top to bottom is we have a 2 on top times 4 x's, because there are x to the 4th. Then we have 5 y's, and all of these are over 4 times only 2 x's on bottom times 2x. Good. And then I have 7 y's also on bottom. So let me get the 7 y's on there. 1, 2, 3, 4, 5, 6, 7. Now what's going to happen here is that 2 over 4 would actually reduce and simplify to 1 over 2. Now x over x, regardless of what this x is, if this number is going to be the same, when they divide, they actually can cancel, because x divided by x would be 1 over 1, which is just 1. If I multiply anything by 1, it does not change. So I can cancel these x's. Since there are no more x's on bottom, I have to leave the 2 x's on top. Now my y's can cancel until I run out on one side or the other. So there's the third y that cancels, now the fourth y that cancels, and the fifth y that cancels. Since there are no more y values on top, I have 2 y's left on bottom. So now I'm going to rewrite the top using exponents, and I'm going to rewrite the bottom using its exponents. Since there are no more exponents shared between the top and bottom, this is your final answer. And that was number 17. So make sure you transfer that answer up top. If you need more time, the sub can pause the screencast, but you do need to have something like this showing your steps. If you can't fit it on here, it needs to go on another sheet of paper. You need to show some steps of some sort. Maybe you're solving it by subtracting 15 and 4 to get 11. In this case, it would be 4 and 2 to get the 2. And then 5 minus 7 would be negative 2, which moves to the bottom when it's a negative exponent. After 17, 18 is very similar. 19 is almost exactly the same. 20 is just like that. So you can make attempts on 17, 18, 19, 20. Give it a shot. If you need to map it out like this, map them out, cancel what can cancel, and show what's left on top, show what's left on bottom, and that's how you do 8.2. Good luck on 8.2. If you have questions, you can email. Don't forget about the tutoring sheet in room number 39. It's outside room 39. If you're going to sign up to get tutored on Thursday, but sign up today. Thanks for listening, and can't wait to see you Friday.